Okay, good morning to all. Uh, so we are in module 3. Already we have discussed about half adder, full adder, half subtractor, full subtractor. Right. So today we'll discuss about binary adder. Okay. Today we'll discuss about binary adder. Again, the strength is very less today. Okay. See, first of all, adder. Adder means for addition operation. Okay. Binary adder means it will add binary numbers. Okay. The logic circuit or the combinational logic circuit which adds two binary numbers known as binary adder. Okay, it is a combinational logic circuit. Why? Because here we are using more than one gates to design the binary adder, right? And it has inputs and also outputs. Okay. So, what is the difference between this half adder, full adder, and this binary adder? First of all, we will discuss. Right. So, half adder already we have discussed. Full adder also we have discussed. Right. So, half adder we have the permission for adding two bits like 1 plus 0. Right. This is a single bit. This is a single bit. We have the permission to add two single bits only. Okay. Sorry. But in full adder, we can add three bits. Okay. Like 1, 0, 1. All the combinations already we know. What are the different possible combinations? Right. So full adder means three digits or three bits can be added like this. In half adder, only two digits or two bits can be added, right? So this bit is different from number. Okay. So number consists of several bits, right? So let 001, right? It is a number. How many bits? Three bits. Okay. Then if I'll write 1010 is the number also. How many bits it consists of? Is a 4 bits. Okay. So a number means it consists of more than one bits. Right. Bit means single digit. Right. So if we'll see. So these two are bits, single bit, right? One is a bit, zero is a bit. So we can add these two bits by using half adder. Okay, these two bits can be added by using half adder, but two numbers cannot be used by using a half adder. That is the difference. Okay, half adder can be used to add only two bits, not the number, right? So here in today's class we are going to design a circuit which will add two numbers, right? A number, it may consist of n bits, right? n bits. Okay, number may consist of n bits. So n bits means n value may be 2, right? Maybe 3, 4, 5, 6, 7, right, up to n, right? So today we'll discuss how to design a binary adder, right, which can add two numbers, and the numbers they are of n bit. Okay, n bit number. Next, another thing I want to say that half adder we don't have provision to add, right? Suppose I'll write two numbers, right? I'll write 101. Okay, then 110 like this, and to add these two numbers. Okay, so this two number can be added with half adder. Okay, because in half adder we have two inputs. Okay, so it has also two bits, so we'll add here. So 1 plus 1 is equal to 0 with carry 1, right? This is sum bit, this is carry bit. Next, when you go to add the next bit, what will happen? We, so the process, addition process is this carry should be added here, yes or no, to the next higher bit. But in half adder, there is no provision to add the carry bit, right? That's why this binary adder can be designed by using full adders only. Okay, we'll use full adders to design a binary adder. Why full adder? Because in full adder we have a provision to add the carry bit. That's why half adder cannot be used to design the binary adder. Only full adders can be used. Okay. So that is the difference between half and full adder. Okay. Next, okay. So before designing the binary adder, we should know the addition process. Okay, how to add two binary numbers, right? These things already you know from your standard one, I think so, right? How to add two numbers. So in binary case also, we'll see the process. After seeing the process, we can design the binary adder, right? Suppose I'll take two 4-bit number. Okay, so let two numbers are A and B. Okay, let A is equal to 1 0 1 1 and B is equal to 0 0 1 1, right? So here A and B are two binary numbers of 4-bit, right? So I want to add these two numbers. Then what will be my process? Okay, so see, see, notations will be like this. I'll tell you. Uh, so in general, I'll write A I, right? A I small I, right? I, it may be 1 2 3 and 4. Okay, so this one represents A1, understood? This one represents A2, this next bit is represents A3, next bit represents A4. Okay, then this first bit represents B1, this one is B2, this one is B3, next this one is B4. Like this, I'll represent like this, right? So first of all, I'll write the numbers. So what are the numbers? First I'll write, this is A1, B1, next A2, B2, next A3, B3. See the notations, right? Then A, A4, B4, right? So values already we know, right? This is, I think, is a 1 1 0 1 1, any number, right? This is 0 0 1 1, right? We can take any number of any length, right? So how we are going for addition of two binary numbers, right? Next, so output you know will be sum bit and sorry, sum bit and carry bit, right? So I'll mention here S1, S2, S3, S4, right? Carry bits will be, see, I'll write here C2. Why? I'll tell you. C3, C4, C5. Then what about C1? Right? What about C1? So C1 will be here. C1 will be equal to 0. C1 will be equal to 0. Why? Right? Why it is 0? See, whenever you are going to add any number, suppose 1110, right? Initially, is there any carry? Initially, is there any carry? In LSB, there is no carry, right? That's why we have to take, assume that carry bit is 0, right? because in full adder we have three inputs, two inputs for, these are the two inputs, but third input should be the carry bit. Okay, so though in LSB we don't have any carry, that's why in LSB the carry value should be taken as 0, right? Whatever carry will generate here, that will be shifted to the next bit. We'll do like this. Okay, that's why initially we have to assume that, or we have to input the carry bit as 0. Understood? Okay, because in LSB the we have to start the addition from LSB to, we have to go towards MSB. So LSB, the carry bit will be 0. Okay, so C1 is 0. Okay, so as you know that we have already yes, you know that we in full ladder we have three inputs. So this is the first input, this is the second input, this is the third input. Understood? Right, then we'll go for addition. So first of all, by using full adder, just add these bits. So 0 plus 1 plus 1 is equal to 1 plus 1, already you know, is a 0 with carry 1. So S1 will be 0, and what about the carry bit? It should be 1, right? And that carry bit is written as C2. Why? Because it is the carry, it is the carry for the second. uh, okay, why C1 is equal to 0? Okay, see, okay, let I want to add two numbers. Okay, decimal number. First of all, I will take decimal number. Let the number is 26 plus 33, right? Okay, then, so what, first of all, what you are doing? You are doing 6 plus 3, right? 6 plus 3 is equal to 9, like that you are doing, right? Okay, then what about the carry here? Carry is 0 here, right? 6 plus 3 is equal to 9. Okay, I will take another number. So I will take 6 plus 4, right? I'll take 6 plus 4. Okay. So 6 plus 4 means it is 10. Okay. 10. 10 means 0 will be here. Carry will be, I should write carry in the next higher bits, right? Why I am writing? In order to add that one with the next higher bits. Okay. So next answer will be 3 plus 2 is equal to 5 plus 1 is equal to 6. So this is the answer. Okay. But initially what happened? Initially this is the LSB, right? This one is the LSB. This one is the MSB. Okay. So we have to start the addition from LSB and we have to move towards MSB. Okay. So whenever we will start the addition, at that time, what about the carry? Is there any previous carry? No, there is no previous carry. That's why we have to assume carry is equal to 0 first of all. Okay. For this MSB, we have the carry is equal to 1. But for this LSB, what is the carry? The carry means it should be generated previously. From the previous bit, it should come. But in this LSB, what is the previous bit? There is no previous bit because this is the starting bit. Okay, that's why we have to take carry is equal to 0. We have to take as a data only. We have to take carry is equal to 0. Okay, while designing the circuit also, we have to take carry is equal to first carry. C1 is equal to 0. Okay, because this is the LSB bit, right? Though this is the LSB bit, there is no previous bit. This is the starting bit. That's why we have to take carry is equal to 0, initial condition. Okay. Next, see. Now sum is equal to 0 and carry this C2. C2 is equal to 1. Why this one is C2? C2 because it is the carry for the second next number. Okay. It is the carry for the next number. Right. So this C2 should be written, right? So we have to shift this C2 to the next bit like this. Okay. So here C2 is equal to 1. Understood? You have to shift the carry bit, right? You have to, whatever the carry generated in the current bit, that should be shifted to the next higher bit. Okay, so here I got C2 is equal to 1. Next, can you see three inputs? What are the three inputs for the next full adder? C2, A2 and B2. These are the three inputs, right? Because in full adder we want three inputs, right? So these are the three inputs. What about the outputs? Next we'll calculate the outputs. Okay. So the outputs will be, see, again you need to add 1 plus 1 plus 1, and we know 1 plus 1 plus 1 is 1 with carry 1. Okay, 1 with carry. So S2 will be 1 and C3 will be 1. Understood? Then the C3 should be taken to the next bit, right? The C3 should be taken to the next bit. So again there is a shifting here. So here, this one is C3, which is equal to 1. Okay. Next, again here another full adder should be used. And what about the inputs? Inputs are C3, A3, B3. Okay. Then let's add these three numbers. 1 plus 0 plus 0 is equal to 1 with carry 0. Okay. So S3 will be 1 and C4 will be 0. Okay. Then next we have to shift this C4 to the next bit. Okay. Then I have to do like this. Okay, right? So here C4, okay, is equal to 0, right? Then I have to add this three numbers. What are the three bits? C4, A4 and B4, right? And if I'll add, then 0 plus 1 plus 0 is equal to 1 with carry 0, right? Understood? Now I'll stop here. Then what will be my answer? Right, I should stop here because there is no there is because this is the MSB bit, right? In MSB we have to stop, there is no other bits, right? So I'll stop here. And what about my answer? So my answer will be, this one will be my answer, I'll show you. So this one is my answer, this one, right? This one is my answer, but there is no carry, that's why I can write down my answer is 1110. If there is a carry, if C 5 bit is 1, what will happen, right? That will be the MSB, right? If carry is there, that carry bit will be MSB, right? If carry, so there is a condition, if carry C5 is equal to 0, if C5 is equal to 0, answer will be answer. Okay, okay, okay. uh, you want to know addition of three ones, okay? Addition of three ones, okay, I'll explain here. 1 plus 1 plus 1, right? Addition of three ones. So first of all, see, if you want to remember this one, you just remember it is 1 with carry 1, otherwise I'll tell you. Okay, see, 1 plus 1 is 0 with carry 1, 1 plus 1 plus 1 is 1 with carry 1. Okay, I'll tell you how. First of all, I will add two numbers, two ones. Okay, so first of all I'll add 2 1, then what will be my answer, right? So 1 plus 1 is 0 with carry 1. Carry 1 means it will be in like this. Understood this one? 1 plus 1 is 0 with carry 1 means I should write like this. So this is not 10, this is 1 0. Okay, because we are not adding decimal numbers. If we'll add decimal numbers, then it is 2, right? But I'm not adding decimal numbers, I'm adding binary numbers. So 1 plus 1 is equal to 0 with carry 1. So 0 will be here, carry part will be go there, like this. Addition already you know, decimal addition, how to write it. Like this, 5 plus 5 is equal to 0 with carry 1 means 10 we are writing, right? Like this, 1 plus 1 is equal to 0 with carry 1. So it is 1 0. Okay. Afterward, again we need to add another one, right? If we'll write, plus 1 again, right, it is 1 with carry 1 like this. So it is 1 1 1 1. So it is right, answer is 1 1 only. The same thing we are doing here. Addition of three ones means 1 with 1 means 1 carry 1, like that we are reading. Understood this one? 1 plus 1, just remember 1 plus 1 plus 1 is 1 1, means 1 with carry 1. That 1 should be added to the next higher bit. Okay, right. Okay, see, next what we are doing, we are finding out our answer. What is the final answer? What is the after adding 2 bits, what will be the answer, right? So the answer will be, see, you have a display board will be there, right? Display board, okay, it may be 7 segment display board. The display board, I am telling about your digital board, right? Display board. So after addition, your display board will show you like this, uh, c5, yes, c5, then s4, S3, S2, S1, like this. So what will be the answer? What is S1? S1 is 0, S2 is 1, S3 is 1, S4 is 1, and C5 is 0. Understood? So this is your answer actually. See, if carry bit is last carry, C5 is 1, means this number will be, it will be, if it is 1, it's not 1, this example, if it is 1, the number will be like this. Otherwise, if it is 0, it may show you only this number like this. Carry bit is 0, means it won't show you, answer will be 1110. If carry bit is there, then that will be your MSB bit. Otherwise, this one will be your MSB bit. This is MSB bit, right? This S4 will be MSB bit. If carry bit is, this C5 is 0. If C5 is 1, then C5 will be your MSB bit. Understood? It depends on the condition, right? If the last carry is 1, that will be MSB bit. Otherwise, the MSB bit will be S4, like this. Okay, this is the process, addition process, binary addition process. Okay, understood this one? Right, next we'll design the binary adder. Next we'll design the binary adder, right? Already I told you binary adders is nothing but addition of two binary numbers, and we cannot use half adder for design. Why? Because there is no option for the carry addition, right? That's why we have to take the full adder for design the binary adder. Okay, so let's go for the design process. Okay, understood this one, the process, addition process. This is how we can go for this process, right? So next, okay, next we will design the uh, adder, okay, binary adder. So first of all, this I'll tell you about this 4 adder, right? We can extend that 4 to n, so we can design n number of n bit adder also, right? First of all, we'll see for the 4-bit adder, right? So we are going to design a 4-bit adder, right? 4-bit adder. See, the question may be design a 5-bit adder, design a n-bit adder, right? Process is same. You just listen it. Afterward, you can design any bit adder, right? Nothing is only we are going for the block diagram. Okay. So, okay, right. So 4-bit adder means how many full adders will require? Each bit one full adder. Remember, right? So 4-bit adder means we have input is two binary numbers, each of 4-bit. Okay, 4-bit means we require 4 adders. Remember, right? First of all, we'll draw the adders. This is the block diagram. We are drawing the block diagram, right? You can draw the logic diagram also. I'll tell you how to draw, right? So these are the 4 blocks. They are the full adders. Okay, they are the, is a short form, full adder, right? This is full adder 1, this is full adder 2, this is full adder 3, this is full adder 4. Already what is full adder, you know, already we have discussed. So how many inputs there in adders? 3 inputs, right? So let's, first one, second one, third one. What about the outputs? Output, again 2 outputs. right? So first of all, I should denote the inputs. This is the output, this is the output, input, 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 output, output, input, 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 the outputs. Okay, so full ladder means three inputs, two outputs. Okay, so next we'll write down what are the inputs. So already you know, for the LSB bit, the carry bit is 0, right? C1 is equal to 0. So this is the carry bit, directly will connect this one as 0, right? Understood? So this is the C1 bit. Okay. Then what about this one will be A naught, this one will be B naught. Understood? Whatever be the number, right? That will be input to this full ladder. LSB bit. Okay. A naught, B naught, they are the LSB bits. Okay. What about the outputs? So output, this is S naught means sum, right? S naught is the uh, first output for some output, right? Not S naught, we are writing one, I think so, right? Better we'll write one, so there won't be any confusion to you, right? We'll write one then. So it's a B1, it's a A1. Okay, this is S1, right? So C1 is equal to 0. We know already, right? Next, okay, right. Then this one is C2, right? Already we discussed. Then this one will be connected to this one. Yes or no? Is there any doubt? Can I connect like this? Right? Then next bit is A2, A3. Understood? Sorry. This one is B, A2 and B2, right? A2 and B2, right? After that, what I'll do? Hmm. This one is S2. This one is C3, right? This C3 is connected to this one, right? Then this one is A3, then B3, right? Then this one is S3, then C4 again. This will be connected to here. This one, this one. Understood? Means directly you can connect to this one like this. Okay, like this. Okay. Next, this one, this bit is hmm, A4, B4, and this is S4. This one is C5. Understood? This is the block diagram for 4-bit adder. Understood? Like this way, you can design for 5-bit also, 6-bit also, n-bit also. So if you want to design for n-bit, so put some dots like this, right? And here you just mention here, this is a full adder for n, right? F-A-N, like this you mention here, and just this will be S n, this one will be C n plus 1, right? And this one will be carry from the previous one. So previous one means it will be n Cn minus 1. Okay, Cn minus 1. This one will be Cn minus 1, and second one will be, yes, Bn and Bn and An. Understood? Or any doubt on this? This will be An, this will be Bn. The same manner you have to go, right? You just see the suffixes S1, S2, S3, S4 like this up to Sn, C2, C3, C4, C5 up to Cn plus 1. Here C1, this one C2, C3, C4 like this. Cn plus n minus 1 will be the last. That one is Cn, not n minus 1. It's a Cn, I think. Cn. Sorry, this is Cn. Okay, Cn. Okay. Next carry will be Cn plus 1, this one. Now it is correct. Understood this one? Right? Understood? Okay? Right? So your binary adder, so this is a see, your binary adder, it can be serial binary adder, right? See, I'll tell you, your binary adder, it can be serial or parallel, right? Serial and parallel. So serial means only one full adder you can use. In parallel, based on the number of bits you can use, right? See, serial means only one full adder you can use, only full adder. So what will be the process? Only single full adder will be there, one memory unit will be there. This is the memory unit, right? Memory means it will store the carry bit. Okay, so again the same thing, inputs a1 a2, inputs are a1 and a2, right? a1 a b1 like this, right? Then it will generate a carry c1, so c1 will be stored in the memory, right? Then again serial means one after another, right? Afterward it will store this s1 bit, right? S1 bit, it will show you S1 bit. After that it will change a2 b2 c2 like this. Then it will show you s2, then a3 b3 c3, then it will show you s4. Means not at a time, you won't check your result at a time, one by one. First s1 bit, then s2 bit, s3 bit, s4 bit, like that. So time taking process, right? This is time taking process. Serial binary adder is a time taking process. But if you go for parallel means that we discussed previously, means at a time the inputs will go. So parallel means how many full adders will require? Same as number of bits. 4 bit means four full adders will require. N bit means n full adders will require. So this is the difference between serial and parallel. Both you can design, right? Serial means only one full adder is required with a memory unit, right? That memory unit is used to store the carry bit. Okay, and this in display it will show you the summation. At a time you won't see, but in parallel at a time you can see, right? Suppose your answer is 1011, so in parallel you can see 1011 in the display. But in serial, what will happen? The display, it will show you, first it will show you 1, next it will show you 1, next it will show you 0, next it will show you 1, like this, right? Understood? Or there is delay. In serial there is delay, in parallel there is no delay, right? Time saving process. You, if you'll go for binary parallel adder, it is a time saver process, saving process, right? In serial it's a time consuming process. Okay, but the thing is that one advantages is there in serial binary adder. One advantages is that is the less complexity, right? In designing we don't require much full adders, only single full adder we will require. That is the advantages, right? It's a less complexity. But in binary parallel adder we require number of full adders, number of connections are there, so complexity will be more in case of parallel binary adder, right? So mostly you have to explain only this parallel binary adder, right? We won't go for this serial, only one or two lines you have to write. I'll forward you notes, right? You have to design the parallel. If binary adder comes means you have to mention the parallel binary adder. You have to go for the block diagram, right? Understood? Or any doubt? So this is about your binary adder, right? It's a theory question, right? Only theory question will come from this binary adder. Yes, binary adder, right? Question will be like this. Discuss binary adder, right? Or write short notes on binary adder, like this question will come. Or design a 4-bit binary adder, right? So you know the design process, you just draw the block diagrams that I mentioned previously, right? It won't ask to you design by using gates. Gates means already you know the design for full ladder, right? Those things you have to mention here. Means uh, what will happen, it will be very, the complexity will be more, I think, right? Instead of this see, instead of the full ladder block diagram, instead of this block diagram, you have to draw the whatever, I think some gates already we have designed na? Like this gates you have to do like this is the sum bit, this is the carry bit, like this, so it won't come, I think so, because it's a complexity will be more, right? You can design by using gates also, or by using XOR gate. You already we know, by using design of full adder by using two half adders. Half adder means XOR gate is there, okay? So you can design like that manner also. Otherwise you can better to draw the block diagram manner, right? It won't ask you to draw the diagram by using gates, right? Understood, right? Otherwise, what you'll do, just replace the full adder with two half adders. That's all. Inputs you know, outputs you know. Within that square, you have to fix the diagram, logical diagram only. That's all. Nothing to do anything else.